Hello friends, Satyendra here, and in this video, let's design nut and bolt, do the assembly and show the animation in Creo Parametric. So let's get started. So here I'll use this drawing to design nut and bolt and this drawing to add the thread. So once you complete the thread and see the section view, your section view will exactly match with this drawing. So this is the external thread, the thread onto the bolt, and this is the internal thread, the thread onto the nut. Now once you complete this assembly and go for mechanism, you can show the animation. Just like this. So if you play the final animation, your animation will play like this. So let's start with designing these parts, and for that go to new, part, solid, assign the name. So this is bolt M10, so I'll take name as bolt M10 and I'll say OK. Now to start this part, I'll start with this bolt head, and for this I'll go to extrude onto the front datum plane, normal, switch off the datums. Now go to the palette, polygons, select the 6-sided hexagon, place here, close it. Now drag this point to this location, I'll make it 10, an angle I'll consider as 90 degree and say OK. So this is the sketch. Now once this is done, say OK. Now this thickness is 0.8D, so this will be 0.8 into 10, which is 8. Make it symmetry and say OK. Now the next feature is these chamfers, and for this go to revolve onto the top datum plane, normal, draw the datum center line somewhere here. Now draw the sketch. So start from here, go like this, come down and close like this. Now the dimension, so this angle is 30 and this one you consider as 2.5. Now once this is done, add a sketch center line somewhere here, select this entire sketch, go for mirror and mirror with reference of this. Now say OK. Go for remove material and say OK. Now if you see this chamfer, this is only in this side, not in this side, but I have created this chamfer both the side. This is because I want to save this part as a nut, and nut is having chamfer both the side. So go to the file, save as, save a copy, and here you write nut M10 and say OK. Now you go to open, select the nut and change the thickness first. So this is 0.9D, that means it will be 9. Ctrl G to regenerate. Now let's create the hole, And for that, go to the hole, switch on your datetime axis, select this surface, press and hold Ctrl key and select this axis. Now go to the standard, select ISO from this drop down list, and from here you select M10. Make it through all, and here you make it through thread and say OK. Now usually for standard hole we follow this procedure, but if you are creating a custom thread, then you need to use helical sweep. But before that, add a chamfer to this edge and this edge. This will be 0.75. So now to create the thread, go to the helical sweep, reference, define. Select the top datum plane and say sketch, normal. Now draw the datum center line first, somewhere here. Create a reference somewhere here. Draw a sketch center line to this reference. Then the helix profile, I'll start from here. I'll go like this. Now the dimension. So from here till here, this I'll take as 0.5, and this side also same 0.5, little extra both the side, and I'll say OK. Now once this is done, go to the section and draw the section. Now to draw the thread section, I'll use this drawing. So I'll start from here, I'll go like this, and like this. Now make it equal. Now this is the internal thread, so I need to follow this drawing. So the distance from this tip to this line is the h, which is 0.5 here. So when your h is 0.5, this base from here till here, this will be 0.577. So let's make this dimension as 0.577. Now add a fillet here to this tip, go to equal, make this line and this line equal. Now the dimension, so this angle is 60 degree, and the distance from here till here, this is h by 8. So if you divide 0.5 by 8, you will get 0.0625. So your sketch is done. Now say OK. Now go to the pitch. So this is your pitch, and this is the gap between this tip to this tip. So this is also 0.577. Now go for remove material and say OK. So now if you go to the right datum plane, view, section, and say OK, normal, you are getting this kind of thread. Now the last feature is this portion. This is h by 4, and for this go to extrude, select this face, normal, draw the circle like this. Go to the reference, select this inner reference, sketch point, place one point here and another point here. Now the dimension, so from here till here, this is h by 4. So if you divide 0.5 by 4, you will get 0.125. Now you say OK. flip the direction, remove material, make it through all. Say OK. Now if you go for section view, normal, you get your thread like this. So you have this step, then this, and then this fillet, which is this step, this, and then this fillet. Save your nut, and your nut is done. Now close it. So the nut is done. So now I'll do the bolt, and for this first I'll edit this revolve. So for the bolt I don't need this portion, so I'll just delete it and I'll say OK. Say OK, Ctrl D. Now the next feature is this portion, which is length of the bolt, and for this go to extrude, select this face, normal, draw the circle. This will be 10 and say OK. This height I am considering 40 and say OK. Now the chamfer, which is this one, 0.1D. So select this edge and 0.1D is 1 and say OK. Now the next feature is creating this thread, and for this go to helical sweep, go to the reference, define, select the top datum plane, sketch, normal. Now first you place the datum center line here, then the helix profile. So I'll start from here, I'll go down like this. Now take a reference to this face, delete segment and delete this segment. Now this height, this will be 26 because I is 40, which is less than 150. So when it is less than 150, then this is the formula 2D plus 6, which is 26. Now this will be my start point and you say OK. Now go to the sketch section, normal, draw the section. And to draw the thread section, once again I'll use this drawing. So this is my external thread, and for this I'll use this drawing. So this time I'll draw like this and this, make it equal. This will be 0.577, add a fillet to this tip, equal, make this line and this line equal. This angle is 60 degree and the gap from here till here, this is h by 6. So if you divide 0.5 by 6, you get 0.0833. Say OK. Now you go to remove material, then the pitch is 0.577. Now I say OK. Ctrl D. Now if you see your thread, you are getting one step here, which is this one, which is not correct. So this step should come out smoothly. So to correct it, once again go back to helical sweep, edit it, go to reference, edit. Now here you just add one line segment, this side, this angle you take it as 75 degree, and this gap you take it as 0.5, the h value. Say OK. So now if you zoom this area, you will see that it is smoothly coming out. Say OK. I see. Now the last feature is this one, h by 8, and for this go to extrude, select this face, normal, draw the circle. Now go to the reference, select this face, close it, normal. Now the dimension. So from this reference till here, this gap is h by 8, which is nothing but 0.0625. Say OK. Flip the direction. This length you consider as 26, the thread length. Now go to remove material. Flip this direction and say OK. And your thread is done. So if you zoom this portion, you see one step here. So before this feature, this tip was sharp. So once you added this feature, now this is having one step, which is nothing but this step. Control D, and your bolt is done. Save it. Now the next thing is assembling these two parts. So go to new, assembly. I'll take name as nut and bolt. I'll say OK. Now to assemble these two parts, go to assemble, select the bolt, go to placement, make it default, say OK. Now the nut, so once again go to the assemble, nut. Now here in assembly you have two different type of assembly constraint. This is static constraint and this is dynamic constraint. So to use mechanism, you should always go with dynamic constraint. So I'll use this constraint. So there are several options here: rigid, pin, slider, cylinder, planar, ball, and other options. Which option I should go? So this depends upon what kind of motion your part is having. So if you see this nut rotates and slides. So there are two motion with this nut. So in that case, you should go with cylinder. So if your part is having only one motion, which is rotation, then you will go with pin. If your part is having one motion, which is sliding, then you go for slider. But my part is having two motion, sliding with rotation, so I'll go with cylinder. Now let's switch off these datums and switch on the datum axis. So now you zoom this portion and you select this axis. Similarly for this part, you select the same axis. It got aligned. Now you go to the placement, transition. Now here I'll select this surface with this surface. Now this will be my 0 position and I'll say OK. So I have successfully applied the cylinder constraint. Now if you go to drag component, and drag your component, this is a sliding motion and this is a rotation motion. There are two motions. So now the assembly is done. Now the mechanism. and for that go to application, mechanism. Now in Creo Parametric, to show the basic animation, we mainly focus on three things. First thing is assembly with a dynamic constant, second thing is connections, and the third thing is the servo motor. So the first thing we have already done, we have applied the dynamic constant. Now the second thing is connections, which is this area. Now here nut and bolt is having a gear type of connection, so we'll go with gear. But why this connection is needed? Because when you go to drag component and drag this component, you see two motions here, but there is no connection between these motions. So to make this connection, we need to use connections. So go to the gear connection. Now here you have gear 1, gear 2 and properties. So select the gear 1 and then select this rotational symbol. Once it's selected, add the diameter. Now this pitch circle diameter you need to calculate from gear point of view. So this will be D, the dia of the bolt, which is 10 minus h by 2, the half of the thread height. So 10 minus 0.25, which is 9.75. Now go to the gear 2 and select the sliding symbol. Now you go to the properties. Now here you have rack ratio. By default it is giving some value. You can change this value with user defined. Now this is mm per revolution. So this value will be my pitch 0.577, because in each revolution of the nut it will move one pitch. Say apply and say OK. So now the connection is done. Now you go to the drag component and drag the same component. Now you see the connections between these two motions. Now once again go to the same connection, edit it. Now in gear 2, just flip this connection. Once again go to the drag component, select the part, rotate it. It should move inside. So it is moving inside. Earlier it was coming out. So now the connection is done. Now the last thing is servo motor. So practically when you have this nut and bolt in your hand, you tighten this nut manually or sometime using spanner. But here in Creo Parametric, to tighten this nut, you need to use the servo motor. So go to the servo motor and select the same rotational symbol once again. Now once it is selected, go to the profile details. Now here you change angular position to angular velocity, degree per second. Now the function type is constant. I will go with table. I will add some rows. Now this will be 0 and this will be 26, the thread length, but always take little lesser than the actual value. So I will take it as 22, then this will be 21 and this will be 1. This is the angle, so I will take it 90 degree and this also 90 degree. Why these values are like this? From 0 to 1 it is 0 to 90 degree, and from 1 to 21 it will be with the constant speed 90 degree per second, and then from 21 to 22 it will reduce from 90 degree to 0. So if you see the graph, you can easily understand. So the speed will gradually increase from 0 to 1 second, then this will be constant speed, and again from 21 it will get reduced to 0 till 22. Now once this is done, say OK and the motor is applied. Now you go to mechanism analysis. Now here this in time you always take the maximum value you have taken in the motor, which is 22. This frame rate you can play with anyone. Go to the snapshot and say run. Now it is running outside, it should run inside. So for that, once again go to the motor and flip the direction. So now this rotational motion is in this direction. Now once again you go to the mechanism analysis. First you change this position to kinematic. Here you take the maximum value for motor in time, which is 22. This you can change to any value. This is the frame rate. Click to snapshot and say run. Now I say OK. Go to playback and play the animation. Now first you increase the speed, change to second option and play the animation. Close it. Now you go to the analysis. Now this frame rate you change it to 25 and once again run it. Say OK. Once again play the animation. So you can play with the frame rate to get the desired output. Now this animation you can convert into a video. You have all the settings here. And once all the settings is done, you can say OK. And it will start converting this animation into a video. And the mechanism animation is successfully done. Now you can comment me if you have anything to say about this video. You can even ask your doubts if you have any, and I'll see you in my next video. Thank you.